and so trying to understand what we see, but mostly what we don't see. And this is where every project is solving a puzzle. And we only have a few pieces of the puzzle, so how to make sense with the few pieces that we can collect and interpret.
That was my lovely guest this week, Gilles Wendling. I'm Taryn Picard, and this is What About the Wetlands, a podcast where we talk all about everything wetland related on Vancouver Island. I was so excited to sit down with Gilles and get to talk all about how water systems work, because obviously water is incredibly important for wetlands. And sometimes it can be quite the mystery to figure out how it's moving, where it's going, and what we need to do to make sure that our water systems are healthy for years to come. We get all that information and so much more in this interview, so I hope you enjoy it as much as I enjoyed being a part of it.
I am Dr. Gilles Wendling, and I am a hydrogeologist. So what are hydrogeologists? Hydrogeologists are people who have studied groundwater. And so I got my PhD in hydrogeology many years ago in '91. And the subject of my research was water wells and how to improve the flow of groundwater to a water well. And I have since worked as a consultant. Half of my career was working with large consulting firms and working mostly for the mining industry and the oil and gas industry, and mostly dealing with their contaminated sites and the contamination due to their activities on the land and effects on water and groundwater. And then I decided to give my expertise, brain and time to protecting water. And with that, I dealt with the protection of watersheds, understanding the interaction between surface water and groundwater, and trying to protect water both for the quality and the quantity of water. And I'm still involved with such project internationally, looking at the impact that people have due mostly to mining activities and building of large infrastructure on groundwater and water.
Awesome. It sounds like such an incredible and diverse career, even for just kind of one topic of water. That's really cool.
No, thank you. No, I feel myself very fortunate to be dealing with the field of water, because water is extremely complex, because water is life and water moves, and there is no two sites which are similar. The nature is extremely complex, and so trying to understand what we see, but mostly what we don't see. And this is where every project is solving a puzzle. And we only have a few pieces of the puzzle, so how to make sense with the few pieces that we can collect and interpret.
Right. That sounds really tough, actually. But rewarding, I guess,
Yes.
right?
Yeah.
So the first question that I ask every guest, the first main question anyway, is how do you define wetlands?
So a wetland, first, is a relatively flat area where water will move very slowly. So wetlands either will I think they are receptors of surface water, so water that comes from the rain or slow runoff. But very often they are also the recipient of groundwater, either water that comes through the bottom of the wetland or flows through the wetland.
Okay.
And they are typically shallow, so you won't have very deep water. And the particularity of wetland is its richness, due to the fact that, like at the bottom of the wetland, typically you have soils and it's rich with organic material, and it has all kind of from bushes to the grass. Cattail, is typical of wetlands, and then you have also the periphery of the wetland with a transition to the forest or to grassland, depending where it is located. And so you usually have a wide variety of species, vegetation that brings a myriad of species, either that are directly water dependent, the fish and the frogs and the salamanders, and then the birds and the dragonflies, and then all kind of ducks, etc., etc. So all those species are interactive. They interact. They depend on each other. So wetlands are considered the second type of land in terms of valuation, in terms of the ecological output. If we can, we can't put a dollar value to that, but I think if we had to build plants or build artificially what the wetlands can produce, it would be extremely complex. And so they are second to estuaries. Estuaries which are the mouth of rivers. So they are, estuaries are the connection between ocean and seas and rivers. And so in terms of the movement of species between the ocean and the rivers, it's extremely rich. And you have also salt water and you have fresh water, so you have a very complex ecosystem. So it's why estuaries are extremely valuable. And as I mentioned, wetlands are second to that.
Okay. So you've mentioned like a lot of things that are very valuable, especially to animals when it comes to wetlands. But what do you think is the most valuable thing about wetlands when it comes to like humans and society?
We are part of the biodiversity. So wetlands are sanctuaries for a very wide range of species which form biodiversity. And so they are part of the change of which we are an element. And so in terms of supplying water, wetlands are also kind of a source of the water for water located downstream. So like looking at the Hamilton Marsh is part of a tributary to French Creek. So it's part of this larger watershed. So every wetland is part of a watershed, and it will supply water and groundwater to the aquifers, and aquifers are connected to rivers. So ultimately those waters will end up in rivers, and they will be end up filtered through aquifers, and they are part of supplying water. They're part of the system, and they can store water due to their surface and due to the fact that water moves very slowly through a wetland. We need elements that slow water, and mostly like with climate change, when we are going to have more water and quicker fluxes of water, having elements that break down the velocity of water is also an asset for nature and for us.
Right. I guess that's mostly because it just helps to keep more water in the systems when we have like dry periods and things like that. Would that be one of the main reasons?
Correct, yes, and it's also a source of water for all the species. As I mentioned, the fish and the butterflies and the ducks, and they also need water, and the deer that will come to the wetland in order to get their water it's a source of water, a source of drinking water. Right. For hundreds of species of animals and birds.
Yeah, so many birds around. Oh, there we go. One making sounds right now. So we're sitting on a piece of land right now that it floods. It's like a wetland, but it's like kind of a working wetland, and it's kind of interesting because this piece of land in Arrington has changed a lot over the past, I'd say, I've been part of this land for 15 years, and even in the 15 years, because of how people have used drainage in other places, this has become a lot more of like a wetland. It's really interesting to me to see like the interaction and how quickly plants will show up in a place that before was like a field. Like we're on the edge right now of where the pond is, but over there's a front field that used to be dry all year round, and then the neighbor across decided they were going to like dam and drain their land, so all that water ended up over here. And now it was like within a year there was like swamp grass growing in that field where before it had been like wheat or whatever it had been. So it's always really incredible to me just to see how quickly nature, what's the word for it? Nature welcomes water, I guess is the best way to
Yes,
say
very
it.
much so. Yeah, 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 yeah. And then it will also like stabilize the land. It would prevent erosion because you have, the grass that settles, and then the root systems are anchors for fine particles and sand and sediment and silt, and so they will prevent the movement of the soil, and so it's an enrichment of the subsurface. And with this enrichment, and if you have organics that comes with it, you have all the elements for more grass to grow and all kind of plants to come and welcome the conditions which are suitable, because you have water and you have soil, so you have all what you need
Right.
to grow plants.
And more nutrients, I guess, sitting there
Yeah.
as well, right?
Yeah. And I think one aspect of wetlands, which is also very worthwhile, is the peace that it brings, because it's an island of space where there is slow movement of water, and the time seems to be going slower. And I think it almost has a spiritual dimension, and this is a big asset.
Yeah. It's funny because that's come up in a few interviews that I've had, is like talking about how, it just gives you this place in a society that moves so fast to just sit and be quiet, and how looking at a marsh, maybe at the beginning it seems like nothing's happening, but the longer you sit, the more you see how many processes are going on just very subtly. And that's not even being able to see under the water and seeing what's going on. That's just on the surface. So. But we as humans are not very good at accepting the fact that we need quiet or stillness in our lives, and that there's value to that quiet and that stillness if we're not involved in it, right?
Yeah. And also the grass around wetlands, they are also shelters and protection for many species, like some of the ducks. I mean, they come and they would hide in it, and they're protected from predators. So there's also this level of safety
Right.
associated with wetlands.
Like sanctuary.
That's correct. Yeah. Yeah.
So it sounds like you have been involved with this for quite a few years as far as like wetlands go. What have you seen as the biggest change over your career when it comes to wetlands and human beings?
We are seeing wetlands historically were not properly considered for what they are. They were considered like wasted land. So historically there were many actions to drain wetlands and to transform them in arable land and close to cities, even just to destroy them and pave them because it was wasted space, and not realizing what they were actually worth. And so now we realize also, by changing the dynamic of watersheds by creating impermeable surfaces, how that gradually destroys watersheds and create conditions for the movement of water that create a lot of problems in terms of erosion, in terms of flooding, etc. So wetlands are elements that work towards an equilibrium, towards an slow and organized movement of water, which is not destructive. And so now we realize that wetlands are actually a very important type of lands that needs to be protected. So because we can quantify it, we can map it, we can visualize it, we have tools where we can actually understand how wetlands are important in watersheds. And there are also international organizations that classify wetlands, and the Ramsar, and so this is very important to elevate the value of wetlands and have them protected.
Are you seeing globally that there is more protection happening, or has it just been like a lot of mouth service where people are like aware that it's needed but not really doing anything?
No, because now it's part of environmental assessment. So whenever you propose to modify the use of the land, you have to look within a certain distance of that land what is present, and wetlands are part of the pieces of lands that needs to be protected and that you need to take into account when identifying the potential impacts that the proposed project would have on the water and the land.
So in most places you're seeing people aren't touching them as much then in that case? There's not...
Now they are on the map. Before they were not on the map.
Right, okay.
So just because of that, they are identified, they are identifiable, and they have to be taken into account when you decide to modify your watershed. And whether you want to build a road or build a subdivision, build a bridge, whatever, you are going to modify locally the land. And you have to understand how the modification of the topography, the modification of the capture of the water, of the runoff, modification of the groundwater, how is that going to impact the neighboring land and the neighboring subsurface?
Right.
And if a wetland is nearby, the interaction between surface water and groundwater is going to be affected. So you need to try to quantify that.
Well, that's good news that is shifting. It feels like we're on Vancouver Island too. There's so much water here, and so much of this land has been wetland for so long. It's hard to look at, I guess, places and know that there was water that was sitting there, and all of a sudden there's like a condo building that shows up.
Mm-hmm.
So it's hard to see, I feel like, on Vancouver Island specifically, how maybe we're valuing wetlands more.
Yeah, and I think they are part of what I would call the water buffer. And so we need in drought conditions to have locations where water is stored, is present, and doesn't evaporate quickly, and is part of this dynamic of supply of water to the rivers, because we don't want the rivers to run dry during droughts. And so you need water which is stored in the subsurface to be this continuous supply of water to the river so that it maintains a low flow during a period of droughts. And wetlands are part of this kind of reservoir close to surface where water is stored and water moves and water is supplied to aquifers.
So if we were to look at like the rivers on Vancouver Island in the summertime, what percentage of the water flowing through those rivers do you think has to do with groundwater that maybe came from wetlands? Sorry.
I think it depends on where you are, but I would say first at the end of the summer, the water that you see in rivers is groundwater.
All of it.
All of it.
So the aquifers that are incredibly important for the rivers as well.
Except if you are close to some glaciers or a permanent snow system, where part of the melting of the ice and melting of the water will be a source of the surface water.
Right.
But otherwise, if you don't have those white patches, then the water that you see in rivers is groundwater. Comes from the ground, comes from aquifers in bedrock and in sand and gravel.
That's nuts.
And so what would be the portion of wetlands? We don't have big wetlands. If you go to the north of BC, the topography is very flat, so you will have very large areas. Here we have generally some slope, so the wetlands will mostly be local and in local flat topography, but you don't have big flat lands. So I would say probably less than 5% would come from wetlands.
Interesting.
Yeah.
So what else would be refilling the aquifers then?
What would be
process?
refilling the aquifers?
Yeah, like throughout the
The
year.
aquifers are mostly filled during the rainy season.
Okay.
This is when you have infiltration through the surface. And then you have also lakes that would be also a source of replenishment of aquifers. Yeah.
All right. So that's another reason that like having land that's permeable is so important. It's because of the like
That's
rain.
correct.
Okay.
Yeah.
So what defines the difference between a lake and a wetland? Is it just depth?
Depth would be definitely depth, and also the accumulation of organic material.
Okay.
I think you would associate wetlands and marshes to a brown bottom.
Okay, yeah.
And lake. You can be swimming, on lakes, and you look at the bottom of the lake, and it's mostly gravel and rock.
Right.
So you don't have much organics. Yeah.
Well, you could probably try to swim in a wetland too. You just might get a little dirty.
You can too. Yeah, it's a different feeling.
Yeah, it would be, wouldn't it?
Yeah.
Find some friends along the way you maybe didn't want to have as friends.
Yeah. But I think that it's interesting. I think there is very often lakes to have outlets.
Okay.
So you have water flowing through.
Right.
And sometimes I remember working in the Kamloops area and with the river, and the river widens. When does it become a lake? What can you call a lake, and what is a wide river?
Yeah.
So it's then there is a question of volume of water and velocity of the water.
Right.
So there are several parameters that would define kind of a lake.
Right. It makes me think of Kootenay Lake, because it's literally just like Kootenay Lake is basically just where like the Kootenay River gets really wide
That's
and then
right.
it gets really
Yeah.
narrow again.
Yeah.
But it's not that much wider than the river is. But I guess it's just slow enough that you can swim and do
and
activities
velocity of the water.
Yeah.
Yeah.
So Siska had a really good question for you too. She was wondering, like, if you look at the northern hemisphere versus the southern hemisphere and how wetlands show up based on latitude, north to south, is it pretty similar how they function and how they form, or is there like a wide variety?
I think it's also a function of topography. I would assume that the Amazon would have a lot of wetlands because of the flatter topography. We associate wetlands with Asia too. I think the way they have worked the land, and you have lots of small and big flat areas where wetlands would be present. I'm just kind of like going through the various continents.
Right.
And the one where you would associate wetlands. And wetlands, I think, I also probably in poorly populated area, not easy to map. What is the boundary? What is the perimeter of a wetland? because it's not a clear transition.
Right.
And if a wetland is partially covered with grass, then you can't really see where the water is present or not.
Right.
So that you need good visual tools, aerial photography or satellite imagery, and then you need proofing on the ground to actually put a dotted line on a map to see this is kind of the approximate boundary of a wetland.
Right. It's not so much to do with latitude as much as it is to do with topography and how flat.
Topography, and I would say precipitation.
Oh yeah, that makes
Yeah,
sense.
precipitation would also be a big factor
Right.
in sustaining the source of water
Right.
reaching the area of the wetland. Wetlands, and also I would say beavers play a role. In Canada, it's an interesting animal because it's an amazing architect, and it will dam a river, and behind the dam you will have water that is going to expand and flood the banks and flood the land, and that you create wetlands next to rivers due to the activity of beavers. And I know in northern BC, where many of the area is flat. I recall a friend, First Nation, who said there are two key elements which control and have controlled over thousands of years the land. It's forest fires and beavers.
Yeah, that makes
And
sense.
it was a very interesting comment for me. I said, oh yeah, these are two key, in the mechanics, in the evolution of the land.
Right.
And it's good to remember.
There was some story about somewhere in Eastern Europe where one of the governments was trying to determine how they were going to change the way that the water system moved in the area, and it was supposed to go to Parliament or whatever to be voted on, and in the time that it took for them to decide they needed to do something to it getting to somewhere to be voted on, the beavers had gone in and done exactly what they were talking about doing, I guess, and solved the problem for them.
Yes.
I can't remember which country that was, but it was a pretty fun story.
Mm-hmm. Mm-hmm.
Yeah, it's interesting to watch actually what's going on in lots of parts of Europe right now with beavers and the UK, because they've started introducing beavers in lots of places again where I guess they were hunted to extinction.
Mm-hmm.
And it seems like it's doing a lot for solving some of the problems with water that people have had.
Mm-hmm. 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 And yeah. And I think it's interesting, the connection between species. I remember watching a documentary on Yellowstone, and how by reintroducing the wolves, so at the top of the chain, how the reintroducing the wolves controlled the population of deer, and the population of deer controlled the type of vegetation and the bush that the deer used to eat, and that stabilized the land, and then the rivers, the quality of the rivers improved. So the water flowing in the river was related to the presence of the wolf. So for me it was also striking to see that interdependence. And I think if we start from the marsh and the very small pieces, we can go up the chain the other way, but I'm sure there is this interconnection. And even mosquitoes. Mosquitoes are very important.
Right.
They are food for the birds, and I think, and marshes are ideal breeding grounds for mosquitoes.
Yeah, and there's so many places in the world that have tried to completely eradicate mosquitoes, which, I haven't heard a lot about how that's affected things, but I'm assuming it's not been great for animal populations. Like Thailand, I can think of specifically. The amount of time, I was there for a month, and the amount of time I spent in the forest and did not see one mosquito the whole time, or and you could see people, they were spraying for the bugs. They'll do the same thing like in the Caribbean on certain islands, so.
Mm-hmm. And there is this little cartoon, say, someone behind a windshield, and 1970s, and the windshield was dirty, and then you have the year 2000 and year 250, and I recall myself, as a child, how dirty the windshield was, and how often my dad, was washing because of all the bugs, you know. And for me, it's not only a cartoon. It talks to me because I experienced it and I see it, and it's true now. You don't have to wash the windshield very often.
No. Yeah, even like in the last 20 years, that's changed a lot. Yeah.
So I think there is the inconvenience, and you know, I think nobody really likes mosquitoes, and so but I think they are here for a reason, and they are a big part of what the birds need, and I think we have to understand that, respect that, and protect that.
I feel like that's kind of an analogy for the marsh too, because a lot of people just look at wetlands, especially marshes, and they're like, ugh, it's just gross water, there's leeches in there, don't want anything to do with it, it's a waste. But it's the same situation where it's so dearly needed for our survival and for the functioning of the whole ecosystem.
And I think they are a big part of watersheds, and I think they need to be understood, they need to be characterized, and then they need to be managed, and they need to be protected and monitored. For me, all those elements are needed, and once you understand an element, you realize how ignorant you were about that piece, and I think for me this is almost with whatever you deal with nature. We say, oh, you know, it's simple, it's not useful, but actually when you look at it in detail, you say, no, wow, I didn't know that was actually it,
Right.
and how important it is from a mechanical aspect, from a filtration aspect, but also from a food chain aspect, and then from a spiritual aspect and a cultural aspect. There are all those elements which are essential.
Is there any point in your career that you can pinpoint where there was like a shift where people started to realize how important wetlands were to civilization in whatever form?
I would say probably yes, the 80s, when we started looking at water and the movement of water differently. There was a lot of perception of water as something that, what's the word for it, that had negative effects, right? Water needed to be captured, piped, and moved somewhere else. And if you wanted to develop the land, right? So, and then suddenly by doing that, we realized that at the end of the pipe, there was a lot of water coming out quickly. And then we started realizing the flooding issues, the erosion issues, and say, oh, what's going on here? And then management of the land with the water and integrating, dealing with water, not getting rid of water, was a shift
Right.
in building and changing the land. And also we realized that managing rainwater and stormwater needed to be done more locally, and the water was supposed that came and that rained on that land was supposed kind of to stay on that land, not to be removed from it. And I think that was a key shift in realizing the dynamic of watersheds, and also realizing what you were doing in the upper part of the watershed affected all the watershed until the mouth of rivers. And in order to not suffer from those large amplitude of flow in the rivers, that you needed to manage every little branches, every little tributaries that was a participant to that flow
Right.
in the mainstream of the river.
That makes sense.
And wetlands being also part. I mean, we see rivers like a tree and branches and small branches, but wetlands are located along those branches at different locations.
Right.
And so they are part of this storage and movement of water.
So have you personally seen any kind of restoration of wetlands that maybe were destroyed before this shift started happening? Like, have you seen communities or governments that have decided that they're going to put more effort into bringing those kind of nature spots back?
I have been involved with river restoration, and very often when you deal with rivers and you try to slow down the movement of rivers, then you create next to rivers areas that become wetland, right? So if you thought, okay, let's create a meander, let's put an obstacle in the river, that remodels and gives a chance to the river to go back to its original movement and taking the time to flow down.
Right. So where's the coolest project you've worked on when it comes to river restoration or wetland restoration?
It's interesting, actually, here locally,
Oh.
I have been involved. Faye Smith was a very an inspiration. She was a dedicated environmentalist, and she was involved with the restoration of the Englishman River.
Okay.
Because the Englishman River, I think it was in the early 90s, where was listed as one of the most endangered river in BC. And living in Qualicum, she took that at heart and realized that we should do better to protect the Englishman River. And she invited me to be part of this initiative. And so we worked in a team approach to protect the Englishman River. So including forestry companies, and there were people with a lot of expertise with fish and fisheries, and so which each tried to better understand the Englishman River. And my role was mostly to look at the groundwater and aquifers, so define the various aquifers present in the Englishman River watershed, and how to better understand how the aquifers were providing water to the river.
Interesting.
And so that was part of this global study and global management plans.
Right.
To look after the river and give a chance to the salmon to be back in the river.
Right.
And it bear fruit, because now the Englishman River is in a much better state, and salmon are back.
That's so interesting, because looking at Englishman River with how many years it gets really, really, really low. It doesn't. It seems like it's still in pretty dire straits some years. So to think, but I remember when there wasn't like any salmon in there. I remember, like as a kid, being told that it was basically like a dead river because of like how much it had lost. So I didn't realize how we got the salmon back. So that's cool to know.
Dave Claw is one of the experts with salmon and fishes, and if you have a chance to interview him, he's also a good storyteller. Yeah.
Nice.
Yeah.
So looking at climate change and how climate change is changing everything to do with our water systems, what is the biggest change that you see when it comes specifically to wetlands?
I see one of the key effects of climate change will be the presence of extreme events and the amplitude of those events. So we are talking about drought and then extreme precipitations. And these conditions, like the extreme precipitations, will create an acceleration of the movement of water at surface. So anything that we can do to slow down that movement of water will be beneficial. And so in that case, wetlands are extremely beneficial because they are flatter areas with the the grass and the shrubs and everything You can imagine that also reduces the movement of water, and then they would also, create kind of a reservoir. They will act as a buffer, and they would release slowly that water back in period of droughts, because we'll have the floods and we'll have the droughts.
Right.
So they are buffers, and so their role will be important and will be very beneficial.
So is there anything you can think of that as average citizens we can do to kind of improve the flow of water in our daily lives?
How we can do, I think we can take part. We can be water guardians. I think we can be volunteer in monitoring rivers, in restoring rivers, getting the fish back. I think there is a lot of those initiatives. Better understanding the river needs time, needs people walking the river, having a thermometer and measuring the temperature of the river. Simple tasks
Right.
that do not require expertise, but are still critical in terms of collecting information. And when we worked, I mentioned our work with FAE and groups in the Englishman River watershed, and there were many volunteers that helped us collect information. And those pieces of information are critical, and they are part of this bank of data that we need in order to better understand and monitor the nature.
So citizen science has a lot of value.
Extremely.
Yeah, okay. That's good to know.
Yeah. And I think our responsibility to to be curious and read and get information about water, I think is extremely important.
So what is the best way to do that? I feel like one of the biggest challenges is figuring out how to get information and how to learn what you don't know, you know?
Yeah.
Like there's so much information out there all the time, but figuring out where to go to learn more about the world around you even can be really difficult.
I think it's a question of identifying water stewardship groups, land protection groups. All those initiatives are part of the web of land and water protection. So I think it's and it can be, I believe in working locally, and then you can, of course, join, the David Suzuki Foundations, the Green. I think we can be involved with actions, and we can be involved with who we support, who we give our money to. I think it's part of the solution.
Right. It's pretty simple sounding.
Yeah.
It makes a big difference, right?
Yeah.
Getting involved can make such a big difference so quickly.
Yeah. And I recall being involved with a school, one of my, the school where my kids went, and we created over, 8 weeks, a little program, and it was a school where there was a little creek that was going next to the school, so that was our study, the little creek.
Nice.
And so one day the kids, and it was like grade 5. So they had even to count the trees within 50 meters, and then another day, someone was working with me, and he was a fishery biologist. And so they looked at the stream and the small creatures that were present in the stream. and so there were another time one of my colleagues came and they said, okay, what is groundwater? So there was an whole element on water and aquifers and how it was important for the creek, and they got some information about those 200 meters of stream next to the school. And I think for me it was a great introduction to watershed dynamic and streams for them. And then at the end they had to make a little poster and share what they had learned with the other people in the school. I think it was great. You can do that, and it's, I was fortunate to have a teacher who was receptive to go a little bit outside of the curriculum But it was great. It was an amazing, for me. I still remember it fondly. It was beautiful.
Yeah, I bet a lot of those kids still remember that too and think about rivers a lot differently because
Very
of that.
much so.
Yeah.
Yeah.
It doesn't take much with kids to get them like really interested in nature and
And I think
that
it's important to also to follow what is being done by municipality and regional districts in terms of projects. If a subdivision is proposed, just what does it mean? Is it good? Is it bad? Are they doing their homework in terms of assessing the impact? I think we need people to be vigilant and say, okay, I can't do anything anyway. My voice won't have any weight. No, our voice can have a weight. So I think it's important.
I agree. And I think that it's shown time and time again, people, like apathy is the biggest thing that destroys life.
And I think too, once we discover a subject, then we realize how complex it can be. And I think if we put a little bit more effort, then we become more comfortable. And then we're not ignorant anymore. We have a little bit of knowledge. And then we keep getting involved. I think this knowledge increases. And should I?
No, you're good.
And I think then you feel, when you are less ignorant, you feel more comfortable. And then for me, it's when you start understanding things, meanings come with that. And then you start breaking walls, you break boundaries, and you expand your circle. And I think it's part of life. It's part of connection. And then you connect to other people who have the same interest. And suddenly you realize you're part of a community. And I think we need that.
Yeah, I agree. 100%.
And watersheds can be a great starting point. Well, I don't know anything about watershed. Okay, so what is what is a wetland?
Yeah. Yeah, and everybody needs water to live. So.
Yeah. And even I'm not a birder, but I had the experience, just to in Colombia, just to go and go with someone who was good at bird watching and say, okay, look here, there is a bird. Here, there is a bird, and you get your binocular out and wow, this is amazing, And then 1, 2, 3, 5, 20 birds, and say, I didn't know there were that many birds here, right? And around wetlands, that's great because there are many birds around wetlands. So this is a great step that can be done also in terms of trying to better understand the life around the wetland.
People keep saying that I should know more about birds, and I'm like, I'm not old enough. I'm only in my 30s. I want to wait till my 50s to pick up on that habit, or it's just going to be a real quick downhill. I got enough nature habits.
Yeah.
Is there anything else in particular you want people to know about wetlands or just water systems in general?
I think it's very important to, when you open your tap, that you know where the water is coming from. Is it good water? Is it water that you can trust? Is it water that contains hidden chemicals that you have no idea is in the water? Because water from the tap comes from a water source, either surface water, where the municipality or the water supplying group takes its water, so it's an intake in the river, or it's a well in the ground that taps groundwater. And then what's above the intake, or what is happening above the aquifer where this well is completed. Yeah, so I think it's important to understand if you are drinking safe water or not. And if there is a problem, identify the problem, and if there is some chemicals that are being used, pesticides over agricultural land, question, is it a good thing? And if it's not a good thing, what can we do to stop it? And then if you are fortunate to live in an area where the water is of very good quality, make sure that that will remain. And so is there a watershed protection plan for the water source? How often is the water sampled and analyzed? Are we also analyzing for pharmaceutical products? Are we analyzing for PFAS, you know, the eternal contaminants? Is it a risk where I live? So I think we need to ask those questions. They are very, very important questions.
So many things to think about in the best way possible from this interview and from chatting with you for this last 45 minutes. I really appreciate your time, and thank you so much for coming and talking to us today.
That was my pleasure.